Hi everybody, today we are going to talk about how to find the slope of a line. So when we talk about the slope of a line, we're really just talking about what is the slant in that line. So we know that we can have a line that is really steep, we can have a line that is really flat, we can have a line somewhere in the middle. So that would be the slope, how slanted is it? And we also can have both positive and negative slopes. So we always read a line going from left to right, just like you read a book. If you read the line or you trace it going left to right, and your pencil is going up, we call that a positive slope. It is going up. Now, if you trace your line going left to right and your pencil is going down, this has a negative slope. So now we're going to talk about some different ways that, more specific ways that we describe slope. So slope, we most commonly refer to it as rise over run. This is an extremely common phrase that you will hear to describe slope. So what do we mean by rise over run? Rise simply means how much you move up or down, and run simply means how much you move side to side. So when we see rise, since rise is up or down, that's just going to be the change in your y values, which just like the y-axis, they move up and down. Run is simply going to be the change in your x values, which run side to side. So another way that you can write change in y over change in x is like this. This is read delta y over delta x. This symbol, we don't read it as triangle, we read it as delta. It's a letter, so we call this delta. And whenever you see delta in a math class, it's going to mean change in. So this and this are exactly the same. This is just like the shortcut for writing change in y, delta y, change in x, delta x. But rise over run is really what we're going to say the most during this unit. Okay, so let's see if we can look at these graphs and determine the slope of each line. So when I look at a line, the first thing I'm going to need to do is pick any 2 points on our graph that seem nice. So we want to choose points that we know, points that are occurring at an intersection, like all of these points. We're not going to pick something in the middle where we don't know exactly where it is. So you can pick any 2 points you want. So let's say I pick this point here at -3, -2, and maybe this point right here at 0, 1. So the first thing we're always going to do, well, we're trying to make it from this point over to this point. However, we can only do this traveling along the grid of our graph. So we're always going to start by moving up or down. Up or down, which is rise, should always come first. So I know to get from my left point to my right point, I need to move up. So I'm going to draw in a little triangle like this. And then I need to move over like this. So these two numbers are going to describe the rise over run. So since I moved up 1, 2, 3 units, my rise is going to be 3. And I moved over 3, my run is also going to be 3. So for each problem, we're going to write rise over run equals, well, our rise was positive 3, our run was positive 3, and then we simplify. 3 divided by 3 is 1. So the slope of this line is 1. Now you can pick any 2 points you want. For example, let's say I picked this point and this point. If I count my rise, it's 4, and my run is 4. Oh, 4 over 4 is also 1. So even though we picked 2 different points, we ended up with the same slope. So you can pick any 2 points from your graph that you know what the coordinate is. So let's try this one together. So let's pick 2 nice points. Let's say we pick here at -1, -2, and let's pick this one here at 3, 0. So I'm going to do, I know that to get from the left to the right, I'm going to start by going up. That's my rise, and then I do my run going over. So my rise is positive 2 because I moved up 2, and then my run is positive 4. So let's write that as rise over run. So once again, my rise is positive 2, my run is positive 4, and if we simplify that, by dividing the numerator and denominator by 2, we get a slope of 1 over 2. So same thing, you can pick any 2 points. Let's say I picked this point and this point. My rise is 1, my run is 2. Oh, 1 over 2. I get the same exact slope. So it doesn't matter which 2 points you pick. Okay, so this graph you might notice looks a little bit different than the other two. The first 2 graphs had a positive slope, but you might notice that this graph has a negative slope. So we're going to see why. So let's pick our 2 points. Let's say I pick this one right here and maybe this one right here. So I notice that to get from here to here, we always go from left to right. I need to first travel down. So when I travel down, that means my rise is now negative. And then I travel to the right, so my run is positive 1. So when I write my rise over run, notice that our rise in this case is negative, which gives us a negative slope. So negative 3 over 1 is just negative 3. All right, so I'm going to have you pause the video and see if you can find the slope of these 3 lines using the coordinates that I drew in, using those 2 coordinates for each line. Okay, let's check our answers. So for the first graph, I see that my rise is positive 4 and my run is positive 2. So my slope is 4 over 2, which is 2. For the second one, I see my rise is positive 2 and my run is 3. So my slope is 2 over 3. And for the last one, I see that my rise is negative 2 because I'm going down, and my run is positive 2. So I have negative 2 over 2, which is negative 1. All right, so now we're going to talk about how we can find the slope of a line if we don't have a graph. So we can actually find the slope of any straight line by using simply 2 points. So if you have 2 points from your equation, you can find the slope using this slope formula. So this slope formula is extremely, extremely important. We will use it all the time, and it is definitely something that you will see in future math classes. So it's really important that you know this formula and that you have it memorized. So the slope formula is as follows: y2 minus y1 divided by x2 minus x1. These y sub 2's and y sub 1's, these just describe the second y and the first y. So it's just a way to differentiate between the 2 y's. So where do these values come from? Well, they come from 2 coordinates from your equation or from your graph. So that first coordinate, we'll just call it x1, y1, and the second coordinate, we'll call it x2, y2. So if you know the 2 coordinates, all you have to do are substitute the values into the formula and simplify, and that will tell you the slope of your line. All right, so let's see if we can find the slope between these 2 points. So for each problem, we're always going to start by writing our slope formula. So I'm going to write y2 minus y1 over x2 minus x1. I would like you to write out the formula every single time. Then the next thing I'm going to do is I'm going to go up to my coordinates and I'm actually going to label them x1, y1, x2, y2. This will help to make sure that we're substituting the right values in the right place. So now, like I said, all we have to do is substitute. So I'm going to set up my parentheses for substitution, and now we just have to replace the values, or replace the variables with their values. So for y2, I see that y2 is 6, so I'm going to place a 6 where y2 used to be. I see that y1 is 4, so I'm going to replace y1 with 4. Notice this negative is built into the formula, so it stays there. Now let's do the denominator. I see x2 is 4 and x1 is 3, so I replace x2 with 4 and x1 with 3. Now all we need to do is simplify. 6 minus 4 is 2, and 4 minus 3 is 1, and 2 over 1 is just 2. So our slope is 2. All right, let's try this one together. So once again, we're going to write the formula every single time, and then we're going to label our two coordinates every single time. And now all we have to do is substitute our values and simplify. Okay, so I see that y2 is 5. I see that y1 is -1. Notice this minus sign is from the formula, and this negative is from the coordinate. So we have two negatives. Be careful with that. I see that x2 is +1 and x1 is -2. So now we've substituted, now we have to simplify. So the first thing I'm going to take care of is these double negatives. Remember, whenever you have two negatives that are right next to each other, they actually become a plus sign. So this is actually 5 + 1 over 1 + 2. Now we can add in the numerator and the denominator, and then 6 divided by 3 is 2. Okay, let's try one more together. So here I'm going to start by writing our formula, y2 minus y1 over x2 minus x1, and label our two coordinates, x1, y1, x2, y2. So now I'm going to substitute the values. I see that y2 is -4, y1 is also -4, x2 is 1, and x1 is 2. So now let's rewrite this as -4 + 4, because remember, whenever we have two minus signs next to each other, they become a plus sign. And then here we have 1 minus 2. So -4 + 4 is 0, and 1 minus 2 is -1, although it doesn't really matter because 0 over anything is just 0. So in this case, our slope is 0, and it's totally fine to have a slope that is 0. That just means that you have a flat line. All right, so I'm going to ask you to pause the video one last time and see if you can find the slope between these three sets of points. All right, let's go ahead and check our work. So notice for every single problem, I wrote the formula and I labeled my coordinates. So for part A, we should have 7 minus 1 over 4 minus 2, which should eventually simplify to a slope of 3. For part B, we should have 1 minus -3 over 2 minus -3, which should eventually simplify to 1 plus 3 over 2 plus 3, which is 4 over 5. And last, for part C, we should have -2 minus 2 over 3 minus -1, which should eventually simplify to a slope of 0. All right, that is all for today's lesson. Thank you so much for watching.